So we're going to let F denote front sprockets. And then we're going to denote R as rear sprockets. So we know that V equals omega R, or omega capital R. And we know that omega of the rear sprockets times the radius of the rear sprockets will equal the angular velocity of the front sprockets times the radius of the front sprockets. We're going to define a D, so this would be the spacing between teeth in the sprocket. So D would be, again, the spacing between teeth in the sprocket. And if we were we can define an equation and say that the number of teeth in the sprocket times the spacing distance will equal a circumference length. So this will be circumference of sprocket. So we can say that ND is going to be equal to 2 pi r. And we can say that R is going to be equal to ND divided by 2 pi, where N is going to be the number of teeth. So we can say that omega R times NRD over 2 pi is going to be equal to omega F NFD over 2 pi. 2 pi's cancel out, the d's cancel out, and we find a ratio finally and say that the angular velocity of the rear sprockets divided by the angular velocity of the front sprockets will be equal to the number of teeth on the front sprocket divided by the number of teeth on the rear sprocket. And for part B, this would be your answer for part A. This is a very important relationship, and you can simply use this to solve for part B and C. So omega R divided by omega F would be equal to 52 divided by 13, and this would equal 4.0. And then for part C, omega R over, or rather, this is supposed to be lowercase r. Omega R divided by omega sub F. This is equaling 42 divided by 28, and this is giving us 1.5. So these would be your two answers for part B and C. That is the end of the solution. Thank you for watching.